Hello, welcome to another lecture on PPS. Today we're looking at a topic called creating and executing C programs. So in this broadly we will learn how does a C program get executed to produce output or result. So it's important to learn about creating and editing files because we can generate new programs only by that process. So the steps for creating and running C programs are writing and editing the C program, compiling the program, linking the program with required library modules, and executing the program. How do you write and edit a program? So to edit a program, the first and foremost step in is writing and editing a program. In order to write a program, you prefer a software called as text editor. Text editor is a place where you can enter, edit, change, store all the code that you want to write in. So the C program that you want to write, you write it on a notepad or like a text editor and then save it with an extension called C. And C is a high level language. So the source code is usually stored in a high level language. And when all your writing is done, you will save it to the file or disk. And this program is called as source code. So therefore, in step one, a programmer opens up a text editor, writes the high level language C code and call it as source code. So in the next step, this source code is taken as input by a program called as compiler. So now the source code or a high level language program cannot be executed because it is a high level language, which is not understandable by the machine. So therefore, you require another program called as compiler that converts a source code into object code. So the output of a compiler is an object code which takes source code as input, and the file is stored with a .obj extension. So compilation is basically a two-step process. The first step is called as pre-processing and the second step is called as translation. In pre-processing, a set of special instructions called as preprocessor commands will be available, which are made substitutions into the code in the pre-processing step. The output of pre-processing unit is called as translational unit, and then the translator picks up the translational unit and converts it into object code. So this object module is purely in machine language, but it is not ready for execution because it has some files that are missing. So those missing files are added in the next section called as linking section. So what exactly happens in step two? In step two, a high-level language source code is compiled by a program called compiler into machine level language code. So a compiler takes the input as source code, compiles it and produces object code. Then we'll process this object code, which is the output of second phase, is given to the third phase called as linking. So what is linking? As we all know that C program is made up of a large number of functions called printf, scanf, cos, square root, etc. Their codes exist elsewhere which are not attached to our program. So here we look up at a software called linker, which is used to link the program with external library files which contain the codes of those predefined functions. So now the extension of all these files becomes .exe. So in the linking phase, all the object code is linked with standard library modules to produce the executable code. Now the executable code is ready to get executed. So in step 3, what happens is object code is taken up by linker that adds it to the standard library modules and produces executable code. So executable code is get ready to be executed and to produce results. So this executable code goes to the final step of processing called as execution of programs. In this step, after linking, we call it as execution. Who executes programs? Obviously, the central processing unit. The CPU takes up using its hardware resources and special commands called as run, takes up this executable code, adds it up to the inputs and produces output or results. But usually the executable code is there in a hard disk that needs to be loaded into primary memory to get it executed. So therefore, here we take up operating system uses another program called as loader that loads that first. The main job of loader is to locate the executable code, place it in the main memory, and then prepare it for getting the output. So the executable code is linked with the inputs to produce the output, and the outputs are usually seen on a monitor or generally may be stored onto a file as well. So what happens exactly in step 4? In step 4, the executable code is attached to inputs, which is loaded into main memory. runs and produces results. And that's how we all see the results. But in any of this process, many times we might not get to the output final answer called as results because of various reasons. And we call that reasons as errors. So in the next part of the video, we will also look at errors. But for now, how do you run a program in general? In practical, the overall process is open a text editor, any C editor, Turbo C editor or GCC compiler, whatever it is, open a text editor, write your code, save it with .c extension, use Alt F9 to compile your program and control. And then if there are any errors, correct the errors and save the code to produce the output. If there are no errors, then press Ctrl F9 to execute or run the program. And when the output is seen, to see the output, press Alt F5 to open up the user screen and check the result. In any of this process, it is pretty evident that we might or might not always end up getting the output for various reasons. And those reasons can be shortly called as bugs or errors. So here we are trying to take a look at what this bugs or errors mean in programming. So what is an error? Error is any situation that causes a program not to run or give wrong output or whatever it is. So error is an illegal operation performed by an user which results in abnormal working of the program. So the program do not work in a normal way. In addition, it works in some abnormal way, either do not work or halt or work giving wrong output. This is what usually happens in programming. So programming errors remain undetected until they are compiled or executed. So therefore, basically errors are of two types. On a general classification, it is compile time errors and runtime errors. Compile time errors can be syntax errors and runtime errors are divided by zero, linker errors, etc. So yes, what are all the basic types of errors that we might encounter in C programs? They are 5: syntax errors, logical errors, runtime errors, linker errors, and semantic errors. Let's have a look at each of them. What is a syntax error? Syntax is nothing but the rule a language follows. So if you write something against the rules of C or C++ language and then try to get the program executed, that is not accepted in the compilation phase. So that becomes a compilation error or compile time error. And one of such compile time errors are also called as syntax errors. And one of that is missing parenthesis, printing value without declaring it, etc. Let us just take up a small example. In this example case one, you're missing semicolon. Example, my printf statement do not have a semicolon. So therefore it throws an error called expected semicolon and it does not compile. So the object code is not produced. So therefore you can't get into action of running the program. So this needs to be cleared. Only then the program compiles successfully. So again, make the change, save your program and compile it again. In the example 2, while is a loop which needs to have some condition inside. Because there is no condition, this program can't run. So therefore it says you have some condition missing. So this is another example of violating the syntaxes of the language, which are called as syntax errors. Then moving up to the next one called as runtime errors. Runtime, as we say, certain errors when you found during the execution of a program or which does not make you get the output, though the program is successfully compiled, are called as runtime errors. So one of such runtime errors is divided by zero and array index out of bounds, etc. are such runtime errors. Example, I unnoticingly divided this number n with zero, so it says runtime error. It throws a warning and doesn't make your program run. On the other hand, there's another type of runtime error that keeps occurring that's called linker error. So linker error is linking, we all know, is a step of program development in which the object code is linked with standard library modules. If we are using some standard functions or some functions in our program and whose code is not defined to that program or not linked properly, then it generates a linker error. Example, I'm using printf but I don't write stdio.h. I'm using strlen but I don't write string.h. In the same way, we all know that C program execution begins with main function, but the name is main all in small letters. Unlike here, check out this program in which main is given in capital letters. So therefore, it throws an error called undefined reference to main. It does not accept, it does not run. This is an example for a linker error. On the other hand, many a times your program compiles successfully, runs successfully. When you see the output, you don't get to see a right output. Example, let's take a small example. Imagine I wrote a program for adding two numbers. In a hurry, instead of writing C is equal to A plus B, I ended up writing A minus B. When I gave 5 and 3, the answer is expected to be 8, but I got something like 2. only then you realize that there might be some mistake in the logic that you have written. So these are those common errors which usually occur when we are in the beginning stage of coding. So this only gets better with practice, or when you write a logic, ensure that you double check your logic to not commit such mistakes. In this program, the for loop is maybe involuntarily, unnoticingly, it's applied a semicolon, terminated with a semicolon. The people who has written this code expected to run it for 4 times and produce loop, 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 loop as the answer, but we ended up producing only once because the for loop is terminated with a semicolon. As I told you, the other example would be C is equal to A minus B instead of writing A plus B, etc. Instead of greater than, I can put less than and forget. All these are few examples for logical errors where there is a bug in a logic that needs to be reconsidered. Logical errors do not throw any warning or any message to the user. Only when checking the output, the user needs to recheck the logic to ensure that there are no bugs in the program to give the right answer. On the last, friend, there is something called a semantic error. Semantic generally means meaning. So if you write something against the meaning of a language or rules of a language, then such errors are called as semantic errors. Here, the semantic error is a plus B is equal to C sounds okay for us humans, but it does not sound okay for machine because the machine expects the L value on the left side, which evaluates an expression is evaluated on the right side, and the answer is supplied to the left side value, which is quite opposite to what we have written here. This does not, A plus B is equal to C, does not serve the semantics of the programming language called C. So therefore, we have an error, and this is called a semantic error. So this is it. Thank you.